Alright, this video covers section 6.6 and we are going to be learning how to solve quadratic equations by factoring. We just spent all of this chapter learning about factoring, and now we're going to use that skill to solve a specific type of equation, the quadratic equation. And quadratic equations have the form ax squared plus bx plus c equals 0. We've already talked about this idea of the a and the b and the c. For it to be a quadratic equation, it has to be true that the a is not equal to 0. Because if the a was not equal to 0, this first term, the ax squared, that would become 0. And then we just have bx plus c equals 0, which now all of a sudden it's not quadratic. What makes it quadratic is the fact that it has that x squared. If it doesn't have x squared, it's not quadratic. Now the way that we're going to solve these is we're going to use this zero factor property. And all the zero factor property says that if you have a product, if you have a times b equals 0, then either the a has to equal 0 or the b has to equal 0. And this should make sense. So let's say I have two things multiplied by each other and I know the product is 0. No matter what the first number is, let's say if it's 5, the only thing that you can multiply 5 by to get 0 is 0. And likewise, if it's the other order, 0 times 5 equals 0. Also, 0 times 0 equals 0. So the only way you can have a times b, or those two things multiplied by each other to get 0, is if one or both of the numbers are 0. So let's see how we can use that to help us solve a quadratic equation. We have this equation. We have x squared minus 5x minus 6 equals 0. This is a quadratic equation, notice, because it has the x squared. And I can't use the zero factor property yet because I don't have something times something, but I know if I factor, factoring is the process of rewriting an expression or a quantity as a product, and that's exactly what we're going to have something times something. We know that this has to be an x and an x, and then we're trying to multiply to give negative 6 and add to give negative 5, and we know this has got to be negative 6 and positive 1, because negative 6 times positive 1 is a negative 6, and negative 6 plus 1 is negative 5. You can also show it over here. I have a is 1, so this has got to be a 1 and a 1. Here a equals 1. C is equal to negative 6. Could try 1 and 6 here, and then when we cross multiply, 1 times 1 is 1, and 1 times 6 is 6. And I need this to equal b, which is negative 5. And to have that be negative 5, this needs to be a negative 6, positive 1, carry those signs over. There you see it, x plus 1 and x minus 6. Those are the two factors. Now, what does the zero product property say? It says that when we factor it, when we write it as something times something and it's equal to 0, then either the first thing has to equal 0 or the second thing has to equal 0. In other words, this first thing, this x minus 6, has to equal 0, or the second thing, this x plus 1, has to equal 0, which is then pretty easy to solve because we know to solve for x, this is a linear equation. We just add 6 to both sides. Same thing here, to solve for x, we subtract 1 from both sides. And so what we're left with is we're left with x equals 6 and then this side we have x equals -1. And with quadratic equations, you're typically going to get two answers. And so we're going to write it as a set of solutions. We're going to use the squiggly brackets, the curly brackets, which are for sets, because we have two answers. We have -1 and 6. Now, a couple things to note here. First of all, in order to use this method, we have to set equal to 0. If it's not set equal to 0, remember in the zero product property right here, set equal to 0. It has to be set equal to 0. And then the other thing that has to be true is we have to be able to factor it. Once we factor it, then we set each of the factors equal to 0, and you're going to have your answer. So that's our note here. In order to use the zero factor property, you need to collect all the terms on one side of the equation so that the coefficient of the squared term is positive, and we need to set it equal to 0. So we got a few examples here. This one, notice everything's set equal to 0, so we can just go ahead and factor. Ways to get 20, we have 1 times 20, we have 2 times 10, we have 4 times 5, but I'm looking for two things that multiply to give 20 and add to give -12. So we're going to have to use 10 and 2, and they both have to be negative. So this is going to be x minus 2, x minus 10. That's equal to 0, so all we did was factor it, bring the equal 0 down. And the only way that this first quantity times this second quantity can equal 0 is if the first quantity equals 0, or if the second quantity equals 0. And you just go ahead and solve. Plus 2 to both sides, plus 10 to both sides, and we get that x equals 2 and x equals 10. I'm going to write it in that set notation again. So this is the set of solutions, the solution 2 and 10. Now the next one looks a little bit more difficult. Hopefully you see that one of the issues we have here is that it's not set equal to 0. We need to go ahead and move this -2x to the other side. We know that when we move it, it becomes a positive 2x over here. Move it to the other side, and so then I'm going to write it in that order that we're used to. The squared comes first, 5x squared, and then now we have the plus 2x over there. We don't have a c term, which is fine. We don't have this plus c term. And this is equal to 0 because now there's nothing left on the right side. And now we want to factor again. Now remember, the first thing that we always want to try when we're trying to factor is we want to factor out the GCF first. You always want to try this first, if possible, of course. It's not always possible to factor out the GCF. But this is an example where it is possible. I can pull what out of these two terms? I can pull an x out. If I pull an x out of the first term, that leaves 5 times x, because x times 5x is 5x squared, and then I'm left with a 2 on the second term. And so now I have something times something equals 0, and it's the same idea. I take this first something here, that has to be equal to 0, or the second something has to be 0. The 5x plus 2 has the 5x plus 2 has to equal 0. Now the only way this can happen So now, just like before, we're going to set the first and the second part equal to 0. We're going to set the x equal to 0, or we could get an answer from 5x plus 2 being equal to 0. Now, we don't have to do anything with the first one. We already got x by itself, but the second one, we're not quite done. We need to move this positive 2 over to the other side. So that leaves us 5x on the left, and now there's negative 2 on the right. 0 plus negative 2 is negative 2. And to solve for x, we need to divide by 5. When you divide by 5, you get x equals negative 2 over 5. So now I have two answers. One answer is negative 2 over 5, and the second answer is 0. Okay, we have some more examples here. Next one, again, it's not set equal to 0, so we need to do some work there. We need to move that to the left, which makes it a negative 3. So we have 2x squared plus 5x minus 3, and that's now equal to 0. And this is one, if you'll recall, it's a little harder to factor. It's not that x squared, it's now 2x squared. And so this is where the tic-tac-toe method comes in handy. The first row has to multiply to give 2, so I'm going to use 2 and 1. Then I have 3 here. So if I do, to multiply to get 3, we have to have 3 and 1. And then we try to cross multiply. 1 times 3 is 3. 2 times 1 is 2. And these have to add to give 5. And the only way that can happen is if this is a plus and a plus, which means this would have to be a plus 3 and a plus 1. And now the problem is that these are, this has to be a negative 3. This has to be a negative 3, but a positive 3 times a positive 1 is going to give me a positive 3, so that's not going to work. Remember, the next best thing to try is to try switching the 1 and the 3, so we'll leave 2 and 1 here. We'll switch up the location. Now when we do this, we have 2 times 3 is 6, and 1 times 1 is 1, and this has to again equal 5. And the only way that can happen is if this is a plus 6 and a negative 1, and we carry our signs over. And now we do multiply to get a negative 3, and so our answer has to be 2x minus 1 and x plus 3. 2x minus 1 and x plus 3, and now we set both parts equal to 0. 2x minus 1 has to equal 0, or x plus 3 has to equal 0. I know if I move that 1 to the other side, it becomes a plus 1, so this is 2x equals positive 1. Divide by 2. X equals 1/2. And then move that positive 3 to the other side, it becomes a negative 3. So my answer is negative 3 and positive 1/2. Okay, one more example here. This is again not in the correct form. What are we going to need to do to set it equal to 0 like we did in the last example? We got that equal to 0. Hopefully the first thing you're thinking is to distribute here. So we definitely can't have parentheses, so this is 13x minus x squared equals 40. And remember, we want the x squared to be positive, so We're going to be better off if we move everything to the right hand side. So this negative x squared, we move it to the right side, it becomes a positive x squared. And this 13x, we move it to the right side, becomes a negative 13x. And so rearranging, we have 0 equals x squared minus 13x, and then a plus 40 that was already on the right hand side. Now we can go ahead and factor two numbers that multiply to give 40 and add to give 13, 8 and 5, and because that's a negative 13, they both have to be negative, and a negative 8 times a negative 5 is a plus 40. So this is x minus 8, x minus 5. Now we set both of those equal to 0. X minus 8 has to equal 0, or x minus 5 has to equal 0. Add 8 to both sides, this side becomes x equals 8. Add 5 to both sides, this side becomes x equals 5. And there's your answer. It's 5 and 8. I have a few more here. So the next one, again, is ugly, and I'm not going to go all the way through this one, but I want to talk about how to get it in the right form. This is definitely not the right form, so what we want to do is multiply out. Remember, this is going to be x plus 2 times x plus 2, and then this is going to be x plus 1 times x plus 1, and don't forget to tag the x squared onto the end. And then we multiply this out, we distribute or FOIL or whatever you want to call it. X times x is x squared, x times 2 is 2x, 2 times x is 2x, 2 times 2 is 4, and this is equal to x squared plus 1x plus 1x plus 1, and then the plus x squared on the end. Go ahead and combine some like terms. We have x squared plus 4x plus 4 on the left hand side. On the right hand side we have x squared plus x squared is 2x squared, and x plus x is 2x, and then this plus 1. Now we're still not set equal to 0, and remember we want positive x squared, and since there's 2 on the right side and only 1 on the left side, let's again move everything to the right. So this is going to be a minus x squared. This is positive 4x, so it's going to be a minus 4x. This is a positive 4, so on the left side it becomes a negative 4. And so since we moved everything over, the left side is set equal to 0. 2x squared minus 1x squared is x squared. 2x minus 4x is minus 2x. 1 minus 4 is negative 3. And you could go ahead and solve from there. I'm going to leave that up to you. Again, here we have another one with g, which is kind of an ugly one, but let's go ahead and think about how we can clean this up. Do you remember how to get rid of fractions? Well, hopefully you remember that we want to multiply everything by the GCF, which in this case is going to be 6. 6 goes into 6, 3 goes into 6, so if we multiply each term by 6 over 1, or 6, even the right hand side to 0, some nice things happen. In the first term the 6 is completely canceled, and so we're left with 1 times x squared, which is just x squared. In the second one, the 3 goes into the 6 2 times, and so we're left with 2 times x, or 2x. and it's a negative, and then 4 times 6 is 24, so this is minus 24 equals 0 times 6 is 0. And from there you factor. Just like the last example, we're going to factor that x and x. What does this have to be? This has to be a minus 6 and a positive 4. X minus 6 has to equal 0. X plus 4 has to equal 0. This gives me x equals 6. This one gives me x equals negative 4. So there's your answer, negative 4 and 6. Definitely one that looked ugly there, but hey, when you multiply by the GCF, it really cleans things up into a nice equation that we know how to deal with. One more example here. Go ahead and pause the video and see if you can figure out f on your own, and we'll come back and talk about it. Okay, so hopefully you were able to get f. If I was doing this one, I would move everything to the left side. So this positive 6x would move over and become the negative 6x. And this positive 24, that would be subtract 24 on that side. So if I write everything in the right order, this would be x squared. 11 minus 6 is positive 5x. We also have a minus 24. This equals 0, and then we go ahead and factor just like normal. 3 times 8 is 24, so if I do x plus 8 and x minus 3, 8 times negative 3 is negative 24, and 8 minus 3 is 5. Then x plus 8 has to equal 0, and x minus 3 has to equal 0. Subtract 8 over, I get x equals negative 8. Add 3 over, I get x equals 3. So my answer is negative 8, 3. And this is section 6.6.